in your life. Your bike wheel rotates, that brings you around. Same with your car. So for the wheels on your car, you rotate around a fixed axis. That's totally fine. That's how you should use a wheel normally. But rotation doesn't need to have a fixed axis. So if I don't hold the axis, I don't fix the axis, it will fall, and your car will fall apart. That's not a good sign. But things won't be that easy when the wheel is rotating. So you can see if I free the axis. Rotation is interesting. Have you guys seen this before? Well, now you have. Now you learn that if the wheel is spinning, it don't act like what you think. This is called precession. Spinning wheel turning is active due to gravity. And you can have something even more interesting if you lower the friction here. This is pretty much the same as the spinning bike wheel. What this thing do is to flow air out of the top, so there's a thin layer of air to reduce the friction. The thing is free to rotate. So this is like a spinning bike wheel, but with no friction. You need to get it spinning. You can see the motion is even more interesting. So I have good news and bad news. The bad news is that something is interesting is very hard. So the good news is we're not going to study it. We're just going to discuss rotation with a fixed axis. Okay? But if you're interested, feel free to take more physics class. So let's first take a look at how exactly do we rotate an object. A simple object is a seesaw. Let's say you put a block over here on the seesaw. So there's gravity acting on the block. In order to move it upward, you apply a force on the outer end. Now, the problem is how big does the force need to be in order to lift the block on the other side? It is not an easy question from the first glance, because when you move it, there's forces interacting with other things. And you don't really know how big the force from the exit is going to act on the rod. The pivot can apply a force in any direction with any magnitude, and you don't know how to solve it. But the trick is to use energy conservation you just learned. Remember that you guys learned this pulley system. If you design the pulley system such that it takes twice the amount of distance to move up the object by d, then the change of the potential energy for the object is the same compared to another pulley, which you just need to move it down by a distance d. So for these two systems, the change of the potential energy is the same. You just leave out the box by the same amount of height. But for this pulley, you need to pull it twice the distance work is going to be the force times the distance you apply the force. So you see, these two pulleys end up increasing the same amount of potential energy. So it's either have F times 2D or F times D. Because the energy change of the two systems is the same, so if it takes longer for you to apply that work, the force you need for applying that work must be smaller. Same with this seesaw system. When you finally lift the box up, the box now at here used to be at a lower position. So there's a change of height, and there's a change of potential energy. When you use a longer stick, let's say longer, the amount of distance that you need to move down will increase with the stick. But no matter how long you increase the stick in this direction, the change of the potential energy of the box is the same, because you always increase the height by h. When you use a longer stick on the right hand side, the distance that you apply becomes bigger, becomes longer. So does it mean that the force you need becomes bigger or smaller?
Smaller.
Good. So you know the answer here depends on how long the stick is. Let's call this R2, R1. Because if R2 is longer, you need to apply the force for a longer distance to move the block upwards. So you know the force you need will decrease. To know exactly how big the force should be, we can get on the page. So when the distance here is R1 and R2, this is R1, this is R2. You move it from here. Then the change of height here and a change of height here will not be different, will not be the same. You can approximate this as the arc length of this pizza, this size of pizza, if you change the angle by a small angle. So the arc length here is the radius times this angle, and that will basically be the height change of on this side. Okay. And to do that, your angle needs to be in radian. So in this case, these two triangles are touching their tip. So the angle is also going to be theta. Then how can I express the distance here, d, with R2 and theta? It's also going to be the same as the arc length.
So R2 times theta.
Yeah. Have you guys learned that? You down the acceleration for for circular motion. When you change your velocity and you bring the two velocity vector together, the change of velocity has a magnitude of the radius times this angle. Do you remember that?
Anytime
So we call this for a 360 degree, and the circumference of a circle is 2 pi r. So if there is a pizza with angle theta, the arclength is 2 pi r and times the amount of angle divided by 360, because the entire circle is 2 pi r. So if you only have theta, then you need to see how many portions of theta is in 360. So we see this formula, and we think it's annoying because there's 2 pi, there's r, there's 360. That's too much. So this is because we are using degree for the unit of angle. If I change the unit of angle into radian, I can just write this arclength as the radius times the angle here. And in this case, the arclength of the entire circle will be 2 pi r, and that should be r times theta for the entire circle. So what will be the angle for the entire circle?
360.
Look at here and look at here. If 2 pi r equals r theta, what is theta?
2 pi r.
Yeah, just 2 pi.
2 pi.
Yeah, r not this one. So in this new unit, the whole circle becomes 2 pi, and this is radian. We define a new unit for angle called radian, so that we can just write this arclength as the radius times this angle. And you can see 2 pi radian equals 360, so 1 radian is 180 degrees divided by 5, something like that. It is useful because you can see the thing is easier. Right? So any other question with this part? You need to know how to do the circular motion acceleration. It might show you final because it is the midterm and